Hey guys, this is Miss Samra. I'm back with my next lesson. One thing I would like to say is, guys, seriously, I miss you guys so much. But anyways, we don't have any other option. Yeah, distance learning is the only way we can do. But anyways, we're doing great so far. So first, okay, today I'm on still, it's 9-2. I'll start off with an example first, just to practice yesterday's lesson. So I have my helper here, would like to read this problem for me. Harjas, could you read this for me?
The numbers of seats in the first 13 rows in a section of an arena form an arithmetic sequence. Row 1 has 13 seats and row 2 has 16 seats.
So you said row 1 has 13,
Row
Second row has
16.
How
many seats are in row 13?
Row 13. All right, that's what we are solving for. Thank you, sir. Really appreciate that. All right. So this is what I have. It's an arena. We have 13 rows in total. First row has 13 seats in there. Second one 16, and my question for you guys is to solve for number of seats in 13th row. How do we do it? So, and also we know it's arithmetic sequence. Let's try setting this up. So normally when you see those arena seats, you know, it's like it goes like this. It's kind of like this pattern, right? So in the first one you have 13, the second one you have 16, and then I'm asking you for the 13th row. And again, I don't want you to spend 5 minutes just like going by that pattern and finding that number. Trust me, it's time consuming. Instead, why not to use explicit rule? Something we learned yesterday. I hope you remember, in order to solve for the nth term, what we do is we take the first term and we add it to one less differences, right? Remember, it's n minus 1 and times it by the difference. So what we need is, technically, we have to have 3 things in this equation. So you have to have first term, you have to have the term you're solving for, and you have to have the difference of this equation. Do we know our first term? Yes, which is the number of seat in first row. I have 13 for A1. Do we know what term we are solving for? Yes, we're solving for the 13th row. So this term would be A13. So first one is 13 seat. And I hope you remember, number of differences always going to be one less than the term you're solving for. If I'm solving for 13th term, it means I have to have 12 differences. And do we know the difference? So every time it's adding up by 3. So the difference is 3. Now the rest is pretty much solving. So 13, 12 times 3 is 36. And if I add these numbers, this becomes 49. So I know in 13th row, I have 49 seats in total. Did I do it right? Yeah, I have 13. Yeah, that's right. Okay, so this is for the first one. If you want to try a got it problem for this, so you can go to page number 699 and you can try got it 4. All right. Okay, now let's move on to next example. Next example is on our second rule, which is called the recursive rule. Recursive rule. Now, let me just show you simple stuff. The easier way to understand this is, because when we did explicit rule, the idea was you had few terms of that sequence and we were trying to find a term which is farther away from the terms we know. So that's when we use explicit rule. Like, you know, first, second, third, and fourth term, and I asked you for 200 term, which is way farther than these ones, right? That's where we use explicit rule. Now, recursive rule, I would say it's more like common sense. Trust me, it is common sense. Okay, now the reason I said common sense, because think about this. If my arithmetic sequence is like, okay, I have 5, I have 7, 9, 11. And let's say if I ask you for the next term, it's pretty obvious because I know these numbers are going up by 2 every time. So it's pretty obvious. I know the next one definitely going to be 13 for sure. And if I ask you for the next one, I know it's definitely going to be 15 because I know I can look at the pattern, I can add the difference and I can find the missing term, isn't it? That's what recursive rule is. So let's try. Let me show you in terms of symbols. What I was looking for this term. Let me use a different color. I was looking for this term. So I was solving for the 5th term. So what I just did is I took my 4th term and I added the difference. Here you go. And trust me, guys, this is just recursive rule. It's more like common sense. You just have to take a term before, add the difference, and that's how we find the next term. Now, the idea is the missing term, it's going to be the term right after the term you know. It's not farther away from the terms you know. It's just the next term. So here's, I just put for the 5th term, but let's say if you have to do it for the nth term. So I would say if I'm solving for the nth term, then what I need is a term before. I hope you remember the symbol. The symbol would be a n minus 1. So if I'm solving for the nth term, you need to take a term before and just add the difference, and that's nothing else. That's the recursive rule. All right, that's one way to use recursive rule. Or let's just say, let me show you another example. Pretend you have this term missing, and I know a term after which is 10, and there's another term which is 15, another term 20. Do you think we can find term before this time? Are we still adding the difference? No, we are not adding the difference anymore because we are actually working backwards. So in order to work backwards, what I'm going to do is, instead of adding the difference, I would subtract the difference. So that's just another way of recursive rule. So let's say if I'm solving for nth term, if you don't know term before, but you know terms after, I'll take the term after, but I'm not adding the difference anymore. This time I would subtract the difference. So that's just another way. So I have 2 different ways to write recursive rule. So it depends on what you see in the problem. You can just use that equation. If you know term before, we use this equation. If you know term after, we use this one here. So let me show you a few examples. So let's say I have a 10th, which is equal to 21, and the difference is 3. And my question to you is, find me the 11th term. Do you think we can do that? Yes, we can do that because I know a term before. I know the difference. So what I have to do is, I'm literally going to take the 10th term, which is 21. I'll add the difference, which is 3, and this becomes 24. Here you go. Let's say, let me just put this problem up different way. Let's say I have an plus 1, which is the term after, is 22, and the difference is, let's just say negative 3 this time. All right. And I'm solving for a nth term. And plus 1 means you know term after. Are we still adding the difference? No, we are not, because this time I know term after and I know the difference. So what I'll do is, instead of adding the difference, I'll subtract the difference. So I'll take the term before, term after, which is this, 22, and I'll subtract the difference, which is negative 3. So if I simplify 22, add it to 3, this becomes 25. Here you go. Again, the idea is what's given in the problem, and based off that, you can just solve for that term. All right. And I have one more thing to show you guys. One more concept, I would say. It's called arithmetic mean, or you can even call this average. Okay, now the reason I said average, because there's a pattern. If you look at the any arithmetic sequence carefully, there's a pattern. Let me just put up one. Let's say I have 5, 10, 15, 20, 25, and dot, dot, dot. This is an arithmetic sequence for sure, because every time numbers are going up by 5. But let me show you a pattern. Let's say if I take my first term and add it to my third term. Okay, 5 added to 15, and if I find their average, what is that equal to? 15 added to 520 divided by 2 is 10, which is equal to the middle number. Let's try with different numbers. Let's say if I take 15 and 25, if I add those two, so 25 added to 15 divided by 2, which is 40 divided by 2, and it's equal to 20, which is same as the middle term. Here you go. Now, the reason this happens, because isn't it both ways? It's the same distance. So technically, the middle number is going to be the average of those two outside numbers. So that's how we find the mean. So basically, if you next time, if you see something like this, you have 2, and there's missing term, and there is 16 here. If I ask you find the middle term, could you do that? Yeah, just because I know it's a arithmetic sequence, I know it is a sequence, so what I can do is, I can just add these two numbers. So it's 2 added to 16, and then I'll divide by 2, this becomes 9. So I know the middle term is going to be 9. Or let's say if this problem is set it up like an minus 1 is 10. An plus 1 is equal to 12. Could you find me the middle term, which is the nth term? Again, it's the same thing. I'll take term before, I'll take term after, which is 10 added to 12, divide by 2. This becomes 22 divided by 2 is 11. So the middle term going to be 11. Here you go. So that's how we deal with these type of problems. And yeah, this is pretty much all for today. If you have any question, you can just put a comment and then I'll answer that question. Thank you guys. Thank you for watching. Stay safe. Bye-bye.